Good morning, dear students. Mr. Khalid Riz is talking. Today we are going to talk about chapter 8 that talks about chemical equation and reactions. And the first lesson in that chapter is describing the chemical reaction. We are going to mention the definition of the equation and what does it mean, a chemical equation. What are the physical indicators for such equation, and we are going to discuss the formula with the number of atoms used in each chemical formula. Okay. So the lesson is talking about describing chemical reactions. Okay. First of all, we need to define or to talk about a concept that concept is supposed to be the chemical equation itself. What does it mean, a chemical equation? A chemical equation is supposed to be a group of elements, we are calling them the reactant, are going to make a chemical reaction, or their behavior in a chemical reaction is to reach to the stability, and we are writing them as reactant. They are to represent the condition of the reaction, what exactly you are going to do to perform such chemical reaction, like heating, adding a catalyst, or even a simple decomposition reaction, double substitution, single substitution, any kind of ionization reaction, for example. What is going to be produced from a reactant? Something known as the product, and the product here represent what exactly came out from the reactant, what happened inside the reactant, what was the condition that is going to make the reactant do the chemical reaction, reaching the stability and produce the product. In that case, the product is a new substance produced due to the breaking down of ions or the element here and forming a new substance here with the product known as the product. For example, if I am writing here a chemical equation like NH4 by 2 Cr2O7, and this compound is known as ammonium chromate, and we can explain why it's 2 here, because chromate group is divalent, so it needs 2 groups from ammonium because it's monovalent. Well, in that case, ammonium is supposed to be between 2 brackets and multiplied with 2 because actually it's monovalent. And such reaction, this reaction is known as decomposition reaction, and we can say that ammonium chromate is going to decompose and produces nitrogen gas in a form of a gas plus Cr2O3 chrome trioxide and 4H2O. And let's stop here for a while and explain why it's 4H2O. For those that they didn't get it, if we said that the nitrogen was 2 atoms, and in the product we got the 2 nitrogen atom here in the form of molecule forming a nitrogen gas, what remains here, it is 4 hydrogen molecule. And don't forget that part. We can say that the 4 hydrogen molecule is going to be formed here in the product 4H2, and we are going to take 4 oxygen atoms to complete the compound for water and producing 4H2O. And in that case, we took 4 oxygen atoms from chromate group, and what's exactly remain after doing the chemical reaction? It is Cr2O3 chrome trioxide. Well, we can say this is known as a chemical reaction, and the symbols here with the chemical formula and everything represent the equation itself. We got here a chemical equation. Okay, so if we want to define what does it mean chemical equation, a minute, sorry for that. If we are going to define the chemical equation, it is simply a research with symbols. The symbols and the formulas that indicate the relative molecular molar amount of the reactant definitely and the product in a chemical reaction. Okay, and that was the equation that we just were talking about. Now something known as the chemical reaction and the indicator, the physical indicator that represent a chemical reaction. Well, okay. For example, if we said that I am having a compound here known as cadmium sulfide, that is a beaker, contain water, and we are going to use two types of salts that when these salts are dissolving in the water, they are going to produce cadmium sulfide, the indicator or the precipitate that I am going to see. That precipitate, after the chemical reaction, we are going to deduce that there was a chemical reaction, and it is supposed to be a physical indicator for such chemical reaction. Okay, the first salt that we are going to use, it is simply ammonium sulfide. And there is another salt, by the way, which is cadmium nitrate. Okay, by adding these two salts here in water and the ionization process, because we can say both are going to dissolve in water, we are going to find that there is an equation or there is a chemical reaction formed, and we are going to know what exactly happened during this chemical reaction. Let's find out. I'm going to say that NH4 by 2 as the ammonium sulfide added to cadmium nitrate using water to perform a type of reaction, to perform dissociation or dissolving process. We can say that that's of course the reactant, and what's going to be produced is a kind of a chemical reaction as a double substitution reaction between the nitrate group and sulfur, cadmium element and ammonium group. Let's find out how exactly this happened. We can see the dissolving process here between the intermolecular spaces of the water molecules is going to ionize both reactant and will produce a precipitate and another type of reaction in a form of aqueous solution. And the aqueous solution is supposed to be formed from NH4 as a positive ammonium ion, nitrate group, and don't forget that we're having another reactant here, which is cadmium positive ion and nitrate negative one. Well, for the nitrate group, they are going to dissolve actually. That is a kind of element that they are going to dissolve. But for cadmium and sulfur, which is the negative one or the negative ion, we will find that the sulfur and the cadmium is going to react together, forming something known as cadmium sulfide, which is a yellow precipitate. And the other aqueous solution here is supposed to be NH4NO3, which is ammonium nitrate in a form of an aqueous solution. Aqueous solution means it's already ionized. It's not going to be deposited. But for the cadmium sulfide, no, actually that's a yellow precipitate from cadmium and sulfur. The reaction of cadmium with sulfur producing cadmium sulfide, which is a yellow precipitate formed from such type of reaction. We can say we get a physical indicator here, which is the yellow color from cadmium sulfide. Let's proceed. As you can see, that's sorry for that, just a minute. Yes, the yellow precipitate from cadmium sulfide. In the other hand here, in that part, the reaction of vinegar and baking soda together, and the evidence of the chemical reaction, or there is a chemical reaction occurs, a formation of bubbles comes out due to the formation of the carbon dioxide gas here. So we can say that the indicators for a chemical reaction to be occur could be a color in a form of a precipitate, it could be a formation of gas, it could be producing heat. Some type of chemical reaction is going to produce exactly heat and light. So we can say the first indicator is the evolution of energy or heat, like what happened in the first equation. And in the second one, the color did change, like what we have here with cadmium sulfide, or even producing of a gas like carbon dioxide gas from such reaction. Okay. Let's proceed to the next part. The chemical equation must satisfy the law of the conservation of mass. The mass is not going to change. Well, okay. And in that table, we are going to mention a specific element. As you can see here, that table, we're going to find that some element in a form of a molecular formula, and the table shows the element that normally exists as a diatomic molecule, something like hydrogen, nitrogen, oxygen, the chemical formula for this element, and the molecular one that they are exist in form of H2, N2O2. You will find that the element exists in a form of a diatomic form, and the table is discussing that the mass of the element, whatever the state of the element in the room temperature, it was a gas or a liquid, whatever, the element mass is never going to change inside a chemical reaction. In a chemical reaction, the element is not going to change. We can say that the mass is neither created nor destroyed inside the chemical reaction from nothing. You will find that the mass did change, just a change from a compound to another. Yes, we got 2 gram oxygen. The 2 gram oxygen will be distributed through the chemical reaction, but it will exist in the chemical reaction itself. Nothing is going to go away unless that there is a chemical reaction, make oxygen gas evolve, or hydrogen gas evolve, or nitrogen gas leave the reaction and go away. And in that case, the mass of the gas, the whole mass of the gas is going to change to another form. Okay. Well, in explaining the word the coefficient number, it is the number written beside the element. For example, when I'm writing 2NaCl, we can say that that is the coefficient number, or that's the number of mole for sodium chloride in that case. And writing a word equation, to write the equation in a form of word, we have here an example about methane and oxygen. And for example, instead of writing that CH4 plus O2, for example, methane and oxygen molecule that's going to produce carbon dioxide and water, instead of writing CH4 or the chemical formula for the element, we are writing it in a form of methane, the name of the element, and this is known as writing the word equation. The equation in a form of words, not symbols. Okay, and as we said before, that the arrow here represent the chemical condition, or what is going to happen inside the equation. Good. Now, with the last part, that lesson, how to write a formula equation or a balanced chemical equation. We are going to clarify writing formula equations. Okay, first of all, we have to know that in writing a balanced formula equation, the equation itself is supposed to be a reactant, as we said before, and an arrow represent the condition of the reaction, and the product in the other side. Make sure that you are writing the state of the reactant, the symbols and the number of moles that indicates the type of the reactant in a specific chemical reaction, and also this is going to be applied with the product, but the chemical condition is supposed to be added: heat, catalyst, ionization, substitution reaction, whatever. So let's take an example. For example, if I'm writing here methane gas CH4, the CH4 supposed to be a gas, so we are going to clarify this by writing G symbol in the form of bracket that represents that the methane is a form of gas, plus O2, that is the oxygen, and it's also the state of the element is the gas. That is going to produce, when methane react with oxygen in the presence of heat, what is going to be produced, it is the carbon dioxide gas, CO2, also a gas, plus H2O, and in that case, what do you think? It is going to be a vapor or a liquid state? Well, actually, it is going to be a vapor. In that case, H2O is a gas too. So, in writing a formula equation and balancing the equation, you are going to perform the reactant to make sure that you are writing the state beside each symbol, writing the symbol itself and the number of moles, or the coefficient number, how many mole we get here: 1 mole methane, also 1 oxygen, that's going to produce 1 mole carbon dioxide, and 1 from water vapor. And in that case, methane CH4 in a form of a gas, plus 1 mole oxygen or O2 in a form of gas. The condition is heating. When you heat such type of reactant, that is going to produce 1 mole carbon dioxide in a form of a gas, and also H2O, water vapor. In that case, we finished the part that talk about how to write a formula equation and how to deal with writing formula equation with the element and the symbols. The table that we discussed before was talking about the molecular formula and the physical state at the room temperature for each element. We discussed how the cadmium sulfide is going to be an indicator that there was a chemical reaction had occurred. Also, formation of bubble or producing a gas could be an indicator that was a chemical reaction takes place. A precipitate, that is supposed to be a solid substance that is going to produce as a result of a chemical reaction in a solution, and that is separate from the solution, that in that case it is a precipitate. Well, thank you very much, dear student, for listening. I really enjoyed talking to you and explaining to you chapter 8, describing chemical reaction. Hope to see you again with extra lessons. See you.